Welcome to you all, and in this short video I am giving you the problems that you have to solve and submit. That is your task in relation to experiment 2. In fact, I have said two problems, and both the problems are straightforward, no complications, nothing. So instead of talking too much, let us show you the problems which I have already uploaded, and this is there are two questions. Question 1 is simple RLC circuit, the values of RL and C, series circuit, initial conditions are given, the switch is closed, whatever is written I am just telling. At t equal to 0, switch is closed. My goal is to find out Vt and this It for t greater than equal to 0, and for different values of capacitances. Okay, most probably they will give you three types of responses that you check. So what you have to do, actually, while solving this, you have to do with your own handwritings and a piece of papers, white papers. Okay, that you write down the equation, which governing equation of the circuit from KVL, and better try to form a differential equation with respect to V. And of course, this time the numerical values of R, L and C are known. So I have chosen these values such that the numbers calculations become easier and numbers come. Although practical unit, that is the kind of capacitances are used, are microfarad range, and similarly the inductance values may be millihenry, more realistic values, but nonetheless I have chosen it so that it will give you some relief. Okay, so those values are there. Write down the governing equation. This is the theoretical part of your report of this question 1. What is that? Write down the governing equation, state this, get the governing equation, and then find out its root, then write down the characteristic equation, find out the roots, and then write down the complete solution. Here, by inspection you have to write it down. Okay, that you do, and then find out the constants which are associated with the natural response by applying these boundary conditions I0 minus and V0 minus. So complete solution will be known. After you get Vt, do CdVdt to get the currents. Very simple problem. And then this you are writing on your own right hand, on your own hand you are writing. Okay, don't copy, one fellow copies other. About the copying I will tell you what will be my decision, but what I am telling, this you have to solve it on your own hand on piece of papers. Find out the closed form solution of Vt and It ultimately. Then on a graph paper you sketch Vt and It against time, and then to the scale you have to do it. Okay, that is the thing. And obviously while submitting, that will be, I will tell in general. So that's all. That is the theoretical analysis of the circuit you will be doing. It will take some 2-3 pages perhaps, but you have to do it for all these three values of capacitances. 3 plots will be there for question 1, which you will be doing with your own hand. No question of using any software, this that comes in. Don't type these things in a Word document. No, that is not acceptable. Okay, right, like you submitted your lab records. So that is the thing. Second thing is, after you have completed this, then you have to simulate this circuit in MATLAB platform. Okay, and where the you find out how to draw this circuit. It's very simple. You are using mobiles with so many options. Here it is similar to that. Simply connect, pick up R, put its value L, C. You go MATLAB, you will learn. Maybe you know by this time because experiment 1 you have done. So make this circuit and simulate it, and connect oscilloscope also. It is available. Okay, and see the current and voltage waveform and plot them. Take the oscilloscope. If you click, that plot will come respective current waveform and voltage waveform across the capacitor. And then in this part, whatever plots you will be getting, I would expect it will be close to the plots that you have got from your theoretical calculations, is not? And while doing the theoretical calculations, I will rather prefer that you don't use any remembered formula. Better just carry on with your calculation. If it has become a first order system, you do it. If it has become a second order system, you do it. So try to avoid using formulas and straight away put the values. That is not a good practice. It will also will give you confidence. So mind you, this is the problem. So BTIT theoretical parts you have to do with your own hands. Go to MATLAB environment. So for this problem, how many things will be there? There will be a theoretical analysis and plots, preferably on a graph paper to the scale, and along with the simulation results obtained from MATLAB. There you should include only 3 things. One is the circuit diagram. That page you take a printout, or no question of taking printout, you just save it and send it to me. And circuit and the 2 plots. Okay, so those things can be grouped together, and in your remarks you say about the conformity of this result to the theoretical results that you have got. That's all you have to do. Very simple problem. Okay, and go through the instructions here, you will get it. Question 2 is, where is that question 2? Question 2 is similar. I mean, no question, I will not in fact repeat it. Only thing, it is not a series RLC circuit, something like this. And this time you solve this circuit. Okay, at t equal to 0 it is closed, it is excited by a current source. So form a differential equation involving Vt. Okay, this is C. I forgot to write there. C, for different values of C, is once again you solve the circuit, try to get Vt and It. Mind you, this time C dVdt is not your It. That is obvious. So form a differential equation with Vt, and after you got Vt, then solve for It, maybe by applying nodal analysis technique, and solve for It. Okay, so once again theoretical parts, and once again you sketch, get the solution, same solutions by using MATLAB, okay, where once again there will be a circuit diagram, the MATLAB environment, and the plots of Vt and It, and once again for 3 different values of capacitance. Here only one thing, part B. So here the first part is initial conditions are all 0. Both capacitor voltage was 0, V0 minus, I0 minus 0. Second part is that capacitor has got some initial voltage. I have not included inductor to be having 0 current, but capacitor, to lessen your burden, is having some initial voltage 5 volt, and then you repeat part A, it will be like that. So I hope the problems are straightforward and you will be able to solve them. So now coming back to the general points, that first part you solve, there will be several pages. So problem number 1, you keep it in one file, okay, in the form of PDF you save it, question number 1. Similarly question number 2, another file. Don't forget to write down in your responses your name and roll number. That is very important. Please write, otherwise. And then you should send the report to my email address, each one of you, okay, with those attached file, so that I can easily identify, oh, this is problem number 1, this is problem number 2. Two files I will expect from each one of you, okay. It will also lessen the size problem of the file, because there will be several, size will be maybe large because graph paper, so you have to scan it and save it as PDF or things like that. Let us try doing this, and last date is 25th October 2020. That is not negotiable, so try to finish it by 12 midnight. You up to 25th October you submit that positively, okay. Now so each one of you will be doing separately. It is expected, of course. Why you should copy from others? But in case if doubt comes to me that these 2 copies are identical in every respect, or almost 90% identical, then it will be my decision. Say whoever is the creator, main creator of the problem, solution, both him and the others whose copies will be similar or almost identical, they will be heavily penalized. Trust me, I will not compromise with that, because in that case you can expect a very poor marks, including 0, both the parties. Therefore try to avoid that. I would expect you will not do that. I hope that. Never do that. And similarly the MATLAB simulation part also, you try to show your own ingenuity, which is different from your friends. Then you will be better marked. And don't write pages after pages. Be to the point what has been asked, and solve them and submit them. And time given is enough, because you have been, if you can solve for one value of capacitance, in MATLAB only change the value of the capacitances. In fact, after you have simulated in MATLAB, at least I will give you any value of RLC and any initial conditions. Also learn how to incorporate initial conditions in L and C in MATLAB environment. So that's all. I don't want to telling like that. So I will mark it like that. There are 2 parts of the question. Each question is having 20 marks. Okay, 2 parts it is having. So Out of 40 I will marks, which will be of course translated into normalized later at whatever level I want. Clear? So total marks will be 40, 20 each, and do it, solve it. And I hope, I'm not sure, as I was telling last class, these lectures, whatever I have done, I always like to talk before the students. It is something new to me. But anyway, I was alone talking, thinking that you are present, and perhaps sometimes talking more than what is necessary, really. But anyway, something I have told, and these are not also very, recordings are not at all has got any professional touch, for which I am to blame. But anyway, it carries the message, I hope, the way I wanted to train you. That is very important, with a deeper look into inductances and capacitances and how to solve the circuits. Okay. So thank you, and solve this and submit in time. That's all. Good wishes to you all.